Okay, so hopefully you've done the Canvas version of this clicker quiz. And if you haven't, then please stop this video now and go back to that page on Canvas and log your answer before you continue with this video. Okay, so point X we have on the diagram right here. And the correct answer is this one, because you need to be able to identify the different phases based on their phase diagrams. Over here is the solid phase, and over here is the gas phase, and then over here is the liquid phase. So since the point is definitely in the solid phase, we can say that the chemical potential of the solid phase is less than the chemical potential of the gas phase. It's less than the chemical potential of the liquid phase too, but that's not one of the answers. Okay, let's go through each of these situations. In order for number one to be true, we would have to be somewhere in the liquid phase, like, I don't know, maybe somewhere right over there. In order for this to be true, again, we'd have to be somewhere in the liquid phase. And then in order for number three to be true, we'd have to be somewhere on the gas-liquid coexistence curve. So somewhere along that line. So the only correct answer is 4. Okay, so to review what we talked about in today's lectures, the phase rule, we saw that one, is related to how many degrees of freedom we have on the pressure-temperature phase diagram. If we're in a region where there's only one phase, then we'll have 2 degrees of freedom, so that means we'll be able to go up, down, left, right. But if we have 2 phases, then we're only going to have 1 degree of freedom along one of the coexistence curves. And then if we have all 3 phases, then we're going to be stuck at a point, and that will be the triple point. Okay, we saw how the enthalpy of sublimation is equal to the enthalpy of melting, fusion, plus the enthalpy of vaporization. The Clapeyron equation gave us the slope of those coexistence curves in the PT phase diagram. And the Clausius-Clapeyron equation allows us to find the vapor pressure based on that slope. And it relates the vapor pressure to the temperature as well as to the enthalpy of vaporization. By the way, this chapter's homework is a little bit tricky, so feel free to log into office hours and get any of the help you need. Also, make sure that you're collaborating with others in the class, either through Zoom or Skype or through some other means. And yeah, get some help with the homework, either from me or from someone else. And I think that's going to be really important to maintain community during this epidemic. So thanks for watching, and see you in Chapter 9.